Hi, today I've got an iPhone SE that's come in doing nothing. The girl has mentioned that it may have water damage. Put a new screen on it because the old screen was pretty bad. So, phone still does nothing. If we plug it in the charge, we can see the phone's drawing 0.01. So that's pretty signature fault for a VCC main short. So let's take this apart and find out what's wrong with it. Pretty rare issue with the SE, but I've found in the past it's been a pain in the ass to actually find out where, because with VCC main shorts, a typical your two diagnosis ways of finding where the short is would usually be to look for physical damage or to inject voltage into the what's called the VCC main line, which is like a main sort of power rail. Now, after looking over this board, we can see that there isn't really any signs of physical damage. The board doesn't have any water damage. It doesn't have any damaged parts at all. All these parts look fine. Take this off. Oh, looks good. Oh, looks good. And parts. Now, a lot of people sort of always seem to get mixed up with these caps because they are kind of brown, but that's not the problem. Oh, looks good. Oh, looks good. Oh, that's good. So look, we could there's different other ways that you could sort of go about this. You'll get a lot of people that will just go and start removing every part that's attached to VCC main, and hopefully one of them fixes it. But let's actually try and diagnose it and find out which part it is. So we've only got to remove one part. So I've removed these two caps at the top here. You can see that they're both missing. I did bump that other cap below it, but we're going to put them back on. And we're going to inject current into this to find out where this short is. So, go. And we'll just put our ground back over here. That'll do for now. Sweet. So we've got our ground soldered to ground, and we've got our live soldered to the two VCC main caps. If we check on the schematics, we've got, the board view in ZXW, we've got the two caps at the top here, which we can see are VCC main. And I'm just going to solder to both of them. So, now, there's not many parts on the top of the board here that actually go to VCC main. Most of them seem to be on the bottom. If we zoom out on ZXW, you can see that. You can see that there's only really that camera part there. You've got the two VCC mains. So there's two VCC main caps at the top, and then on the back, we've got quite a few coils and caps and chips that are using that line. So what we're going to do is inject voltage into this and see which part heats up first. Now, typically, if you go in and use and sort of plug voltage into that battery connector, the only thing that's going to get hot is the MOSFET, and we know it's not the MOSFET. The MOSFET will always get hot, and we know it's not that because the MOSFET doesn't have a line to ground. It's just a connection between VCC main and BAT VCC. So that's not going to be our problem. But it will always heat up, and it will generally troll people, and everyone will think it's the MOSFET. It's the MOSFET because it's getting hot, but it's not. It's just something on that line that's getting hot. So we would expect a cap that has gone bad or something that would basically turn into a wire that's not supposed to go to ground, and it's going to get really angry when we heat it up. So let's put freeze spray on this and see if we can figure out what part heats up first. So, our magic freeze spray. Okay, now with that on, we're going to turn the power on, and bingo, didn't that go hot fast? So did you see that cap? Then it went really nice, no snow, and then just watch this cap. Should be the first thing to melt on that board. Bang. So what's that cap do? Let's turn our power off. And let's go back to ZXW. Bingo. He's on VCC Main. We'll test that one more time. I just fully lost track of which cap it was. Oh, he just went back. He just went off again. So, sweet. And you can see by looking at that, that's got literally, there's no sign that that looks bad. He looks fine. So, what's that there? Let's just take off our wires. We don't need them anymore. And we're going to go back over the back of the board here, and we're going to get rid of this bloke. Make the camera a bit smaller here so you can see what I'm doing. Okay, so he's gone, and now if we come back over, you could measure it from where we just were, whatever floats your boat. We want to measure VCC main again and see if there's a short. So if we use our continuity mode and we measure the ground, our VCC main short is gone. We are in continuity mode, we are measuring VCC main, and there is no short. So let's see if the phone boots. These are actually a really good phone. If anyone's looking for something that's a relatively cheap iPhone that's cheap to fix, you're going to pay about 100, 120 bucks to get a screen done on one of these. The phone outright I think is about 350 to 450 depending on where you get it from. And there's very little common issues with these SEs. The only thing that really seems to commonly affect them is the TriStar replacements, or like this, like a spontaneous VCC main short. But this is a rare issue. I only see this myself being a repairer, but your TriStars are really your only common type sort of repair for these, and that's not something that's unique to the SE. It's something that affects every iPad, iPod, or any Apple device with a lightning port uses a TriStar or some variation of it. So not unique to this phone, but you know, it's a good cheap buy. It's reliable. It's strong. I think it's by far the best iPhone, which is obviously why Apple stopped selling it. So let's check it on charge again. Let's see what happens. 0.27, 0.8, and we're charging. Oh, you can't see that because I got plastic on, but oh, we're on. There we go. So if you ever get an SE with a Spontanius VCC Main short, you've got a method to find it or fix. And we should turn it on now. Done.